Are you aging quickly? Is it really just a matter of age? Have you noticed that many people are not very old, but are in poor health? They have sallow complexions, sagging skin, prematurely gray hair, and low energy. Even people in their 30s look more tired than those in their 50s. When you ask them about it, they say, "I'm getting old. Maybe it's because I stay up late too often." However, an increasing number of studies tell us that this premature aging is likely not caused by age, but rather by a certain molecule silently attacking the body. Hello everyone, I'm Nyokashiwa. Welcome to our Health Science channel. Today, we'll discuss the culprit behind this premature aging, free radicals. The chain reaction they trigger is called oxidative stress, Today, we'll delve into it at the cellular level. Where does it come from? How does it attack you? And how can you reverse it? Section 1. What are free radicals? Why are they called the molecular madmen of the body? Free radicals are a type of byproduct inevitably produced during the body's energy metabolism. Their characteristic is that they lack an electron, making them highly unstable. Imagine free radicals as uncontrolled, lonely molecules that frantically steal electrons from surrounding healthy molecules in their quest for an electron partner. This behavior essentially amounts to attacking cellular structures. The three primary targets of free radicals: proteins, causing denaturation and rendering them unable to perform physiological functions; DNA, triggering genetic mutations and potentially inducing carcinogenesis; lipids, fats causing cell membrane peroxidation and disrupting the cellular barrier. What's more alarming is that free radicals are not only unstable themselves but also replicate more free radicals during attacks, triggering a chain reaction that spreads like wildfire. This leads to what is known as oxidative stress. Section 2. What is oxidative stress? This microfire is consuming your body. Oxidative stress refers to a situation where the number of free radicals produced in the body exceeds the body's ability to eliminate them. Like a miniature fire spreading unchecked, ultimately destroying critical tissue structures. In this state, cells are attacked, protein functions are disrupted, DNA is damaged, and tissue structures break down, leading to various signs of premature aging. Skin loses elasticity, developing wrinkles and age spots. Brain fog, forgetfulness, difficulty concentrating. Muscle weakness and slower recovery. Persistent inflammation and immune system dysfunction. Decreased cardiovascular elasticity and abnormal blood pressure fluctuations. If time is the clock that makes us age, then oxidative stress is the hand that forcefully presses the fast-forward button on that clock. More importantly, it not only accelerates aging, but is also explicitly identified as the culprit behind various chronic diseases. Section 3. Which diseases is oxidative stress involved in? You may never have noticed. Modern medicine has confirmed that oxidative stress is widely involved in the development of the following diseases. Neurodegenerative diseases. Alzheimer's disease, free radicals attack neurons and disrupt synaptic transmission. Parkinson's disease, damage to dopamine-producing cells leads to impaired motor function. Depression and anxiety, chronic inflammation and oxidative stress jointly affect the neurotransmitter system. Cardiovascular system. Atherosclerosis, oxidized cholesterol is more easily recognized by the immune system and forms plaques. Hypertension, oxidative stress damages vascular endothelial cells, impairing vascular dilation. Cardiomyopathy, mitochondria suffer oxidative damage, leading to reduced energy supply to cardiac muscle. Cancer and cellular mutations. Free radicals attack DNA, causing genetic mutations and activating oncogenes. Simultaneously, they reduce cellular repair mechanisms, allowing mutations to accumulate uncorrected. Diabetes complications. Retinopathy, neuropathy, and kidney damage are all associated with microvascular oxidative damage. Glycation and oxidation often reinforce each other, forming a vicious cycle. Eye diseases. Cataracts and macular degeneration are both associated with prolonged exposure of eye tissues to a free radical environment. In summary, free radicals plus oxidative stress equals accelerators of chronic diseases and aging. Section 4. Where do free radicals come from? You produce them every day. Free radicals are not external enemies, but rather byproducts that are constantly produced during normal metabolic processes in the body. The primary sources include mitochondrial respiratory chain, natural byproducts of sugar and fat combustion. High carbohydrate diet, blood sugar fluctuations and insulin spikes stimulate the excessive production of free radicals. Chronic stress, elevated cortisol levels increase systemic oxidative reaction levels. Smoking, alcohol, and environmental toxins, all can induce increased oxidative reactions. Excessive exercise or lack of sleep affects recovery ability, leading to the accumulation of oxidants. Plant oils and processed foods contain easily oxidized polyunsaturated fatty acids. Interestingly, the harder modern people work to live, the more prone they are to oxidation. Working hard, staying up late to work overtime, controlling their diet, excessive dieting, or running. If proper repair mechanisms are lacking, free radicals will accumulate over time. Section 5, the body's defenses. How does the antioxidant system work? Fortunately, the human body is not completely defenseless. We have an innate, antioxidant system that silently protects us every day. This system consists of three main components. Antioxidant enzyme system. Superoxide dismutase, SOD. Glutathione peroxidase, GPX. Catalase, CAT. They act like firefighters, actively eliminating excess free radicals in the body. Small molecule antioxidants. Glutathione, GSH. Vitamin C, vitamin E, coenzyme Q10, uric acid. They act like fire extinguishers, stabilizing free radicals while repairing cell membranes and DNA. Gene regulatory factors. NRF2 is the overall commander of antioxidants. It can recognize stress and activate the body's antioxidant emergency response mechanism. But the problem is, this system is prone to collapse. Especially in modern lifestyles, long-term nutritional deficiencies, excessive stress, and sleep deprivation can leave you without fuel for the fire extinguisher, let alone extinguishing the fire. Section 6, why has your antioxidant system collapsed? The following are the most common causes of antioxidant system collapse in modern people. Insufficient protein intake, glutathione and enzyme systems lack raw materials. Avoidance of fats and cholesterol, weak cell membranes and deficiency in fat-soluble vitamins. Insufficient B vitamins, metabolic reactions cannot be initiated. Excessive intake of plant oils, large amounts of oxidized lipids block metabolic pathways. Lack of trace elements such as selenium, zinc, copper, and manganese, enzymes cannot be synthesized. Chronic anxiety, late bedtimes, and insufficient sun exposure, disruption of melatonin and cortisol rhythms, indirectly overwhelming the immune and antioxidant systems. The antioxidant system is not solved by taking a single vitamin C tablet, but rather it is the comprehensive manifestation of the body's self-healing system. Section 7, why is the ketogenic diet considered an antioxidant strategy? The ketogenic diet is gaining increasing attention. Not only because it burns fat, but also because it fundamentally reduces the production of free radicals. The antioxidant mechanism of ketosis. Ketones are a clean fuel. Compared to glucose, which produces more free radicals when burned, ketones leave almost no waste residue. Activates the NRF2 pathway. Directly enhances the expression capacity of antioxidant enzymes. Reduces high insulin levels and glycation reactions. Reduces the root cause of chronic inflammation and lowers oxidative stress. Improves mitochondrial efficiency. Reduces engine smoke and optimizes energy pathways. Rich in animal fats, cholesterol, and vitamins A, D, E, and K. Repairs cell membranes and stabilizes the nervous and hormonal systems. It is not merely antioxidant, but rather rewrites metabolic logic to eliminate the fundamental causes of free radical production. Section 8, which nutrients are essential as antioxidant raw materials? Your antioxidant system requires raw materials to function. The following are key nutrients that must be prioritized. Nutrient function. High-quality protein foundation for synthesizing glutathione and antioxidant enzymes. Vitamins B1, B2, B6, B12 initiate enzyme reactions and cellular repair processes. Vitamins A, E, K liposoluble antioxidants that stabilize cellular membrane structures. Selenium, zinc, Copper, manganese essential coenzyme factors for antioxidant enzymes. Saturated fats, cholesterol provide stable structural support for cells. Coenzyme Q10, L-carnitine support mitochondrial function and restore energy systems. Supplementing these nutrients is not just about health preservation, but about equipping your body with a complete firefighting system. Free radicals are inevitable, but they are not unsolvable. The real issue is whether you can maintain a balance between clearing and repairing. Alright, that's all for today's science popularization. I'm Neo Ketone. Remember, I hope you all stay healthy. Next episode. Leaky gut, your body's defenses are quietly breaking down. You might think it's just stomach discomfort. But in reality, toxins and inflammation are quietly leaking out of your intestines. It could be the root cause of your chronic fatigue, allergies, and emotional breakdowns. In the next episode, we'll uncover the truth. What is leaky gut? How do high-carbohydrate diets, vegetable oils, and antibiotics compromise your defenses? Why is the ketogenic diet key to repairing the barrier? Follow us and don't miss out. Please remember. Disclaimer. The content of this video is for health education and nutritional science reference only, and does not constitute medical advice. Before making any dietary changes or health decisions, please consult your doctor or nutritionist. Translated with dpel.com, free version.